Hello everyone, I am Dr. Velamani Pierce, Professor, Department of Computer Science, University of Science and Technology in Meghalaya. In this video, we are going to see about machine-to-machine versus Internet of Things architectural overview, building the architecture. So in the M2M versus IoT architectural overview, so the following are the areas which we can have a glance: building the architecture, the main design principles and needed capabilities, an IoT architecture outline, standard considerations, reference architecture and reference model of IoT. The first one is building the architecture. So the how the architecture of the IoT can be built. So it is the thing which we can see that to identify and authenticate all entities involved in the IoT services. So all entities which are all called gateways, endpoint devices, home networks, roaming networks, service platforms. So these are all the entities which is involved in the IoT architecture, and this particular authentication is used to identify all these entities. Then it is used to ensure all user data shared between the endpoint device and backend application is encrypted. Complete with local data protection legislation so that all data is protected and stored correctly. So it takes the network level approach to security in addition to device level approach. So first the network level security approach in addition to the device level approach, which is going to build the architecture. There are certain constrained devices and networks. So most IoT sensors are designed for a single job, a specific task, and they are typically small and inexpensive. They often limited power CPU and memory, and they transmit only when they when there is something important. So the limited power CPU and memory will be utilized only during the transmission time. The network that provide connectivity also, it's tend to be very lossy and support very low data rates. This is completely different situation from the normal IT networks. So IoT requires a new breed of connectivity technologies that meet both the scale and constraint limitations. M2M IoT architectures, 1M, 2M architecture, the IoT world forum. So these two areas we can see to it. So the 1M2M IoT standardized architecture. This standard is developed initially the European Telecommunication Standard Institute, that is ETSI. It was created this M2M technical committee in the year 2008. The goal of the M2M is to create a common services layer which can be rapidly embedded in the field devices to allow communication with the application server. So various network devices can get the information or get the software application from the servers by using the common services. One M2M framework focuses on IoT services, applications, and different platforms. So one of the greatest challenge in designing an IoT architecture is dealing with different type of devices, softwares, and access methods. So if it is a single device or a single application software, access method is Simple one means the number of protocols will be less. So it deals with different type of devices, which will be a complex fact to deal with the different devices. Managing and controlling of all these devices. It requires a lot of software and accessing methods. So by developing a horizontal platform architecture, one M2M is developing standards that allow interoperability at all levels of the IoT stack. For example, we might want to automate our HVAC, that is heating, ventilating and air conditioning system, by connecting it with wireless temperature sensors uh, spread throughout our office. So in this situation, the designing pattern needs to be considered. The temperature sensors also will be used for the heating and ventilation and air conditioning systems. So we'll see that horizontal and vertical layer level of the one M2M IoT architecture. So the main elements of the one M2M IoT architecture, there are three layer levels in the application of 1 to M architecture. So this particular diagrammatical representation which takes place the network layer application talks to the, this is the particular application in the smartphone. There are different applications available in different devices, and this application talks to the API, application programming interfaces, to communicate the sensors. That is the network layer level. So in the services layer level, there is a horizontal layer and as well as the vertical layer level. So this particular point we need to take into this particular direction, which is talking about the service layer. So in the vertical manner, if you'll see to it, different applications are available, different application which is said to be the application layer level. Then we can see the automotive application, the home applications, the energy applications are in the vertical layer limits. So for all these vertical layers, we are going to provide the common service layer and the communication technologies and protocols and the communication networks and the communication these devices and hardwares. So this one M2M includes a common service horizontal framework, so which we are seeing able, which we are able to see the horizontal pattern of the framework supporting RESTful APIs. So in this manner, these major or main elements are in the M2M IoT architecture. The major domains, that is the application layer, the service layer and the network layer. The application layer, the machine-to-machine architecture gives a major attention to connectivity between devices and its application. So various devices that will be connected to its application, that will take care the priority number one. Then the domain includes the application layer protocols and attempts to standardize northbound API definitions for interaction with business intelligence systems, that is BI systems. The second thing is service layer. So this layer is shown as a horizontal framework across the vertical industry application. So which we have already seen in the figure, the horizontal framework across the vertical industry application. At this layer, horizontal module includes the physical network that the IoT application run on, the underlying management protocols and the hardware. The background communications via cellular or MPLS networks or VPN and so on. Riding on the top is the common services layer. The conceptual layer adds APIs and middleware supporting third-party services and applications. Now the network layer. This is the communication. domain for the IoT devices and endpoint. It includes devices themselves and the communication network that links them. Communication infrastructure includes wireless mesh technologies such as IEEE 802.15.4 and wireless point to point to multi-point systems such as IEEE 802.11. Now the IoT World Forum standard architecture. It is a seven-layer IoT architecture referential model published by IoT World Forum Architectural Committee, Cisco, IBM, Rockwell Automation. So in this, edge computing, data storage, access are the consideration. The edge is about the processing the data closer to where it's being generated, enabling processing at a greater speed and volumes leading to greater action lead results in real time. So that is the edge computing. So it is the processing of data closer to where it is being generated. So the generation point itself we are processing the data and enabling the processor at greater speed and volumes and leading to greater action lead results in the real time. So on the generating data that will be stored in the data store, which will be used for the accessing purposes. Now the IoT reference model world forum. So in this, there are seven levels which we can see here. So the number one is physical devices and controllers. That is the things in IoT. These edges are called sensors, maybe devices, some machines, intelligent edge nodes of all types. So here we can see some of the devices also and the connectivity that is used for the communication and processing, the switches and robots and you can see the routers and a different type of data storages also for the usage of data communication and processing purposes. Edge computing at this moment, the data analysis and transformation of data from the connectivity to the accumulator. So the accumulator is the storage which is going to be give the aggregation and access for the data abstraction purposes. Then finally the application will get the reporting analytics control. So the after reporting analysis control, finally the data will be communicated with the collaboration purposes, collaboration and processes, which involves people and business processes. So the first thing is edge devices and at last the various center can access the information. This is the IoT reference model in IoT world forum. So now we can see one by one layer level. Layer number one, physical devices and controllers. So the endpoint devices and sensors, which we have seen already, the size of the things can be range from almost microscopic sensors to giant machines in the factory. So that may be the level, very minimum level to maximum size, the number of devices that will be utilized here. Their primary function is generating the data and being capable of being queried or controlled over a network. That is the physical devices and controllers layer. Number two is connectivity layer. This is the important function of the IoT layer, which is the reliable and timely transmitting the data. More specifically, this includes transmission between layer 1 devices and the network and between the network and information processing that occurs at layer 3. So which we have seen in the figure itself. So the connectivity, we can have a look on this, the communication and processing units. Layer 2, so communication between layer 1 devices. So reliable delivery of the information across the network. So here different switching and routing will be used. Some of the translation between the protocol also will be considered. Then the network security level data storages and robotics can be takes place for the further processing of the information. Edge computing layer. So the fog layer in which a series of nodes receives data from IoT devices in the real time. These nodes perform real-time processing of the data that they receive with millisecond response. So once the nodes receive the data from the IoT devices, the nodes perform real-time processing of the data when they receive with the millisecond immediate response time. At this layer, data reduction and converting network data flows into information that is ready for storage and processing by higher layer. One of the basic principle of the reference model is that information processing is initialized as early and as close to the edge of the network as possible. Another important function is evaluation of the data. This is also for data to be reformatted to make the additional processing by other system very easier. Then the third one is edge fog computing, which we have seen that in the previous explanation. So the functionality, the data packets will be ready for processing at the higher level. So the functions evaluate the reformat data for processing at higher level. Then they filter the data to reduce traffic higher level processing, access data for alerting, notification, or other actions. Data accumulation layer. So it creates data and store. It is so it is very useful to other application whenever it is necessary. Convert event based data into the query processing. Data abstraction layer. So it takes the essential data that satisfy certain characteristics from the stored data and supplies it to the application layer for the further processing purposes. This layer focuses on to provide data and its storage in ways that enabling developing simpler performance enhanced applications. The sixth one is the application layer, which is going to be act as a interface between IoT device and the network. It handles the data formatting and presentation and serves the bridge between the IoT device is doing and the network handoff of the data it produces. It interprets data using the software application. This application can provide data on monitor, control and reports based on the analysis of data. The seventh, the last one, that is collaboration and process layer. It provides response or action to be taken against the data provided. So this action, for instance, ever can even be an activation of an electromechanical device upon the instruction from the controller. So now let us see the data flow in the IoT architecture. So first, from this layer level, we can see data gathering that will be done by the sensing layer. The physical objects, sensors and activators will be there in the sensing layer. So the data will be observed by using the sensing layer. See, the environmental data, the live data will be observed at this particular layer level. Then after that, it will move to the network layer, that is data which is used for the data transmission. So this network layer consists of different devices like internet gateways, gateways, and network technologies, that is data acquisition system. So the transmitted data will move to the data processing layer. So this data processing layer will take care of the processing of the information, which consists of processing unit, data analysis, and decision unit. A big data can be stored in this particular layer level, and with the predetermined logic or predefined data sets, the decision can be taken by the decision unit. So finally, the processed information or the action or the output or the result that will move to the application layer level. So the actions can be takes place in the smart application under the management. So that is our application user interface level. So with this data flow from the sensing layer to network layer to data processing layer, finally to the application layer. This process can be done in the IoT architecture. So this is the four stage of IoT architecture view. So the advantages of using seven layer, the initially we have seen the collaborative layer, collaboration layer also. So with the seven layer, what kind of advantages if you'll see to it? The IoT problem will be divided into small parts, which is decomposed, and it will identify different technologies at each layer and how they relate to one another. It will define the system in which different parts can be provided by the different vendors, that is different suppliers. Have a process of identifying interfaces that leads to interoperability. And also it defines a security model. This is enforced at the transition points between the two levels. So that is the advantages of the seven layer model. Now the IoT disadvantages. The security, it's a little control depicts any security measures. So this leaves users exposed to various kind of attackers. So the IoT creates an ecosystem of constantly connecting devices communicating over a network. So in such a moment, there might be a lack of security. We can find attackers can easily attack the any devices communication and they can retrieve the information. So the privacy, the sophistication of IoT provides substantial personal data in extreme detail without the user active participation. So without the user participation also, this very important privacy personal data will be available in the internet. Complexity, some find IoT systems complicated in terms of the design, deployment, and maintenance, given their use of multiple technologies and a large set of new enabling technologies. So the complexity will comes once the movement, if we are connecting with a large number of systems, then the deployment, then the design, then the maintenance cost, everything will get varies. That is also a disadvantage which we can consider here. The flexibility, so many of the concerned about flexibility of an IoT system to integrate easily with another. The worry about the findings themselves with the several conflicting of the locked system. So in the IoT device communications, the flexibility part, if we want to integrate some additional devices, so sometimes it cannot be possible because some private devices that can be locked at this moment, the network cannot be established properly. Now the IoT outline view. So the architecture refers the tangle of components such as sensors, actuators, cloud services, protocols, and layers that make up IoT networking systems. In general, it is divided into layers that allow administrator to evaluate, monitor, and maintain the integrity of the system. So now we can see the framework which is presented in the two parallel stacks, the IoT data management, the compute stack, and the core IoT functional stack. So in the core IoT functional stack, applications, communications, things that is sensor and actuators. So this can be takes place the security level, the IoT data management and the compute stack will consist of the cloud edge in between that fog also considered. Thank you very much. Thank you all.